In this video, we're going to try and find the sixth derivative of this. So we are trying to find the sixth derivative of this evaluated at 0. So if you try and differentiate this 6 times, it becomes very complicated. So you start out with this, differentiate it once, that will then give you this. Now you've got to use the product rule. So the product rule is differentiate this, leave this alone, then that will then give you this, and then leave this alone, differentiate this, that will then give you this. Now tidy the whole thing up, that will then give you this. Now if you try and differentiate this again, then you've got to use the product rule here, and then you've got to use the product rule here, and so on. It becomes very complicated. So to evaluate it, to find the sixth derivative of this evaluated at 0, turn this into a series. So turn this into a series. Okay, so hang on. So turn into a series. So turn this into a series. So imagine this as being x to the power of 3 here. So you've got to put x to the power 3 into here. So that would be, so this will be negative 1 to the power of n, and then this will be your negative 3. This will be your x to the power of 3, and then to the power of 2n to the power of 2n. Well, turn this into a series. That will then give you this. Now tidy this up. This times this will then give you this. So when you get to this stage here, visualize this. Now when you come to differentiate this 6 times, you see differentiating this 6 times is very complicated. When you differentiate this 6 times, this will disappear. If you differentiate this 6 times, you would get whatever, something over, and then you've got differentiate it 6 times, you would get something along the line of to the power of 6. And then when you come to evaluate it at 0, then you've got to put 0 to this x, and then the whole thing disappears. If you differentiate this 6 times, you have something, and then for the x, you have x to the power of 12. And then when you come to evaluate it at 0, you've got to put 0 into this x here, and then the whole thing here will disappear. The point is that when you turn this into a series, and then differentiate this series 6 times, you see this block here will give you something interesting. This one here will just disappears. It will be 0, and then this thing here will be 0. But then when you come to differentiate this 6 times, all right, differentiate this once, it would be minus x. Differentiate this 6 times, it would be something along the line of 6x to the power of 5 over 2 factorial. And then when you come to differentiate it again, it will be minus 6 times 5, and then x to the power of 4 over 2 factorial. When you come to differentiate it again, it will be 6 times 5 times 4, x to the power of 3 over 2 factorial. And then, well, you can see the pattern here. If you differentiate it 6 times, it will be 6 factorial over 2 factorial. Okay, so when you come to differentiate this 6 times, you would just be left with a constant, and it will be this constant. And then evaluate it at 0. Well, there's no x in here. So the sixth derivative evaluated at 0 will be minus 360. Okay.